Hello friends, welcome to my channel. In today's video we will talk about how to solve second order ordinary differential equation using SciPy. So here we have our equation d square y by dx square is equal to x dy over dx whole square minus y square. So we have to solve this second order ordinary differential equation with these initial conditions. So how are we going to do it in Python? So there is no direct method to solve these types of equations numerically, though you can solve them using SymPy, but sometimes it won't work. So in these types of cases, what we do is we convert second order differential equations into system of first order differential equations. So how does that work? Let me show you. So what we have done here is we have let dy over dx is equal to z, and after substituting this value in our differential equation we get two coupled differential equations. First is this itself, and note that these are the initial conditions. So y0 is equal to 1. This becomes initial condition of this equation. And for the second one, we have when we have substituted this into our main differential equation which we have to solve the second order one, we get this, and z, which is dy by dx, its initial condition becomes 0. So here it is. So let me show you how to input this in Python. So first of all, we will import some important modules. NumPy library we will use for arrays, matplotlib for plotting, and this is our main thing. ODE function we will use to solve the ordinary differential equations. And what is this? I'll show you in a few minutes. So first of all, we will define our function. Let me show you how to define this function. This is a bit tricky, but I'll try to show you. See, you can't exactly find logic here because this is a type of code which developers have developed to solve these types of equations, and that type of codes are intensive codes. You won't be able to understand it. So it is just a way to define them in Python because we are using inbuilt function to solve them. Okay, so this statement might get you confused, but in short it is called unwrapping. Y is an array of two like two values are there in y. Okay, so y is getting 1 and z is getting 1. This all happens in computation part. We don't have to worry about it. You just have to write it this way: y comma z is equal to y, and return this array. First element is this z, and second element x z square minus y square, which is the right hand side part of this equation. Then we have to put linspace array in the range for which we want to solve our equation. In my case, I am solving it for 0 to 10. And that's how we have to input our differential equation in ODE function. First, we have to put the function, then this is the initial condition array. Remember to put in square brackets as we are giving two values in an array form. So what is this one? This is this y0 is equal to 1, and this is the second initial condition y0 is equal to 0. So because these are two differential equations, coupled differential equations to be exact, we will get two solutions in an array form. In solution, we will be getting two solutions. So first one is our main solution for y, and second array is z solution. And remember that z is dy by dx, nothing else. So let's run this code and see what we get. So here we go. So here we are getting two equations: yx This is our y function, the main solution of our differential equation which we need. And this red one is the zx. Zx is the derivative of this function and nothing else. So this right now we do not need zx, so let's just eliminate it. And to get this type of interface, I have used this notebook keyword. If you use inline here, you will not get the interface to get values of y for each point. So keep in mind this is very important. So here we have got our solution and we can get y values for whatever x values. You can see here are these values. So let's see what we have to find. We have to find y to 0.2 with accuracy up to 3 decimal places. So how to get this much accuracy? First of all, let's zoom out in this region. From 0 to 1, I will get my value. So I am zooming this area. You can zoom as much as you want until you get desired accuracy. 0.2, 0.2. So you have to just coincide your this plus sign with this equation as much as you can. Let me try to just overlap with it. It's a little bit hard, but it doesn't really matter because it will affect your answer's accuracy by very less number. So let's take it this much. So our y value is 0.98014. I'm taking up to 5 decimal places and it is correct up to 5 decimal places. 0.98014. Back to our value. So we can just print it is 0.98014. Our required value of y is 0.2. I hope you have understood it. If you didn't get it, you can ask me in the comment sections. And if you want this code, I'll provide you the link in description box as well, or you can scan this QR code. Just scan this code and you will be there. I hope this would have given you some insight into differential equations in Python. Thanks for watching. Consider subscribing my channel if you like my content.